Hello students, today we are going to discuss the second lecture of differentiation, that is differentiation part 2. Okay, so in today's lecture, first we are going to discuss a real world problem on the differentiation, and we can say that the differentiation by a real example. Okay, so start. Basic concept of differentiation. What is differentiation? To understand, let's take an example. Suppose I start my traveling from Gandhinagar to Vapi via Ahmedabad, Vadodara by car. Suppose I start my journey at 7 a.m. and I reach Vapi at 12 noon. It took total 5 hours to travel 360 kilometers. Distance between Gandhinagar to Vapi. So, my average speed from Gandhinagar to Vapi was 72 km per hour, that is 360 total distance and 5 hour total time. So, distance by time, that is 72 km per hour. So, I was not constantly driving my car at the speed of 72 km per hour. During some interval, my speed was more than 72 km per hour, and during some interval, my speed of car was less than 72 km per hour. So my position at different time is shown in table and graph. So let's start the position with the help of the table. See, journey start at 7 a.m. So the total distance cover is 0 because we are at Gandhinagar at that time. After 15 minutes, I reached at Ahmedabad. So I traveled total 20 kilometer. Okay. So the average speed between Gandhinagar to Ahmedabad is 20 upon 15 minutes. So 0.5 will convert into the hour. So average speed between Gandhinagar to Ahmedabad is 80 kilometer. Okay. Which is more than the total average speed 72 kilometer. After 1 more hour, so at 8:15 a.m., I reach at Vadodara. Okay, so the distance between Ahmedabad and Vadodara is 110. The distance between Gandhinagar to Ahmedabad is 20. So total distance between Gandhinagar to Vadodara is 130. So the average speed between Ahmedabad to Vadodara, that is 110 upon 1 hour. Total time is 1 hour. So 110 by 1. So the average speed between Ahmedabad to Vadodara is 110. After 1 more hour, at 9:15, I am at Bharuch, right? So the distance between Vadodara and Bharuch is 65 kilometers. The distance between Gandhinagar to Vadodara is 130. So the total distance is 195. So the average speed between Vadodara to Bharuch is 65 upon 1, that is 65 km per hour. Now at 11 a.m. after 9:15, then 11. So 1 hour and 45 minutes, right? At Surat. So the total distance between Gandhinagar to Surat is 270 and the distance between Bharuch to Surat is 75. So the average speed between Bharuch to Surat is 75 upon 1.75, that is 42.85 km per hour. And at last at 12 noon at Vapi. So the distance between Surat to Vapi is 90 km. Total distance is 360 km, that is from Gandhinagar to Vapi. So the average speed between Surat to Vapi, that is 90 upon total time cover is 1 hour. So 90 by 1, that is 90 kilometer per hour. So dear students, this is the average speed which we find through the table. Okay, this is nothing but this is the slope, and in other word we also see that this is the derivative. Now the same thing we'll understand with the help of the graph. Here this graph, okay, this graph indicate, here x axis indicates time, t for time, and the y axis indicate distance, total covered distance, right? So at 7 a.m. at t equal to 0, our starting, this at t equal to 0, this starting, this one is Gandhinagar. After 15 minutes, okay, after 15 minutes, we covered 20 kilometer, that is Ahmedabad. Then we go up as time goes at 8 a.m., 9, 10, 11, 12. Okay, at 12, total distance covered 360 kilometer and we are at Vapi. In between, Vadodara, Bharuch, Surat, okay, these are the destinations. So here, this axis indicate time, total covered time, and the y-axis indicate the total covered distance. Now, with the help of this, we calculate the average speed. We calculate the average speed between any 2 points. Average speed during an interval between any 2 points, or we can say between any two cities. Okay, so I can calculate the average speed during any interval mathematically as well as graphically. Let's find the average speed between Vadodara to Surat graphically. Okay, this is the example. At this one, this indicate the Vadodara, this point indicate the Surat. Okay, at Vadodara, at t equal to t2 time we reach at Vadodara. Okay, and the total distance covered from Gandhinagar to Vadodara is 130. So students, this T2 and T2 which indicate the total time covered to reach at Vadodara, and this F of T2, F of T2 that indicate total distance from Gandhinagar to Vadodara. Now this T equal to T4. T4 indicate the time, total time covered at to reach Surat, and F of T4, these indicate the total time covered at total distance covered to Surat. So the average speed between Vadodara to Surat, if we want to check graphically, we have to just find out the slope, this slope, and for this slope, the total distance between Surat to Vadodara. This is the total distance. This is 130, this is 270. So 270 minus 130 is just 140. So the total distance is 140. Total distance, total time here, this 11 minus this T2. So this is 2.75. So final answer is 50.9. By graphically, again I repeat, the total distance upon total time. The, the slope, we want to find the slope. For finding the slope, the total distance upon total time. Okay. Now, the same thing, if we want to find with the help of the mathematically, let's find the average speed. let's find the average speed between Vadodara to Surat mathematically. Then average speed between Vadodara to Surat for the mathematically, this is, as I told you, this point indicates T4, f of T4, and this point indicates T2, f of T2. Okay, so this one and this one. So this is the formula, f of T4 minus f of T2 upon T4 minus T2. So by substituting the value f of T4 minus f of T2 and T4 minus T2, and by simplifying you get the answer. Both answer will be same. So it is easy to find the average speed between any two cities or between any two points. But if we want to find the exact speed at the particular city, or we can say the at particular point, at that time, how to calculate? How to calculate the exit speed? Here we have find the average speed. Now we are going to find the exit speed at Bharuch. So, for the exit speed, for the given example, I reach Bharuch at t equal to Ta. Okay. Suppose this Ta is 9:15 am. So, at 9:15 am, I reach at Bharuch. So, dear students, this point indicate Ta and f of Ta, right? So this Ta is 9:15 and this f of Ta, this is the total distance covered. Here the total distance covered is 195, right? Now, if I want to find the exact speed at this point, then I have some different cases. First case, here my TA is, as you all know, my TA is T equal to TA at reach at Bharuch, that is 9:15. So I just take a small interval which include this 9:15 am. So for that, if I take my first interval is 9 to 9:30, okay, which include 9:15. So this is at 9 am, total distance covered is 180, and at 9:30 am total covered distance is 205. So this is the formula to find the average speed. So t f of ty minus f of tx, then ty minus tx, f of ty minus f of tx, then ty minus tx. At tx means the time, f of tx is the covered distance at this particular time tx, ty is the another time, and the f of ty is the total distance covered at Ty time. So by substituting all these four values in this formula, and finally after simplification we get the answer 50 kilometer per hour. Okay. Now in second case, if I take a smaller interval, see in this interval I have taken 9 to 9:30. Okay, so it is bigger. But if I take in case 2, if I take smaller interval than case 1, at that time if I take 9:10 to 9:20 means 9:10 to 9:20, which also include 9:15 this time. Okay. So at 9:10, the total distance covered is 190.8. At 9:20, the total distance covered is 200. So by substituting again the same formula, by substituting all value, we get the answer 55. Right? Now, in third case, if we go for again the smaller value, now in third case, now in third case, if we go for again the smaller value, my interval is 9.15, 14 to 9.16. Okay, so at 9.14 total covered distance is 180, and at 9.16 total covered distance is 20. Here are some mistake in this the value, but the answer is right. So by substituting all the value we get 54. So through this case, we can say that as to get the exit speed, to get the exit speed, to get the exit speed at Bharuch, the selected time interval that includes t equal to Ta should be as small as possible. So Ty minus Tx should be as small as possible. So ideally Ty minus Tx should be very close to 0, not exactly equal to 0. So for getting exact speed at Bharuch, Ty minus Tx should approach to 0. Okay. So this Ty minus Tx is close to 0. Ty minus Ta is again close to 0, and Tx minus Ta is close to 0. So we can say that the exit speed at Bharuch from left side and the exit speed from Bharuch from right side. So the both answer will be equal. The exit speed at Bharuch is possible to determine. Okay, if the exit speed at Bharuch from left side and the exit speed from Bharuch from right side, if both answer will be equal, the exit speed is possible to determine. So the exit speed at Bharuch is given by limit t tends to Ta, f of t minus f of Ta upon t minus Ta. So the limit t tends to Ta, f of t minus f of Ta, that is t minus Ta, is known as the differentiation of the function f of t. Student, I explain this real world problem because I just want to explain you this formula of the differentiation. Okay, this formula is known as the differentiation formula of function f of t with respect to t at t equal to Ta. So graphically, differentiation of any two function f of x at x equal to a is tangent to the curve y of fx at x equal to a. Okay. Now we'll move on the example which we already learned in yesterday's lecture. So let's ready with pen and paper. I will ask anyone. So let's start. My first question is, if I have y equal to log 7 2x minus 3, and if I want to find the derivative, what will be the first step? Anyone? I am going to unmute you all, but I ask the particular students, and that particular students will unmute him or herself. Okay? Yes, Kushan.
Ma'am, first we will apply base changing theorem.
Yes, good.
Log 2x minus 3 divided by log E7.
Yes, yes. Yes, Kushal. Log 2x minus 3
Minus
upon,
3 divided by log 7.
yes, right?
Now we
Now,
will derive it.
yes, now these logs, here both the base are e. Now for the derivative, this log 7 is the constant term. So log 7. And the derivative of this log 2x minus 3 is what?
1 by 2x minus 3 into 2.
Perfect. 1 upon 2x minus 3 into d by applying the chain rule, d by dx of 2x minus 3, that is 2. So our answer is 2 upon log 7 2x minus 3. Yes. The next one is y equal to 2 raised to x cube. Y equal to 2 raised to x cube. Anyone? Raise your yes, Hetvi.
Ma'am, first we'll take log on both sides.
Yes, Hetvi. Yeah, we can do with by taking log on both sides, but I will give you a hint. Uh, See, dear students, you know the formula of a raised to x, right? That is a raised to x log a, right? If we have y, then this one is the y dash. So by applying this formula, I have y dash is equal to 2x raised to q log 2. Now apply the chain rule, that is d by dx of x cube. So 2x cube log 2 and into the derivative of x cube is 3x square. Okay. Now the next sum is y equal to e raised to 3x into cos 2x. So students, here we are applying u into v rule. So e raised to 3x, keep it same. Derivative of cos 2x, that is minus sine 2x, plus cos 2x minus sine 2x into 2. E raised to 3x, keep it same. The derivative of cos, that is minus sine theta, will remain the same, into d by dx of 2x, that is 2, plus cos 2x, keep it same. The derivative of e raised to 3x, that is e raised to 3x, as it is the exponential function, and then again apply the chain rule, that is d by dx of 3x. So our answer is, the derivative of this 2x is 2. So minus 2 e raised to 3x sine 2x plus 3 cos 2x e raised to 3x, right? So by getting e raised to 3x common, our answer is minus 2 sine 2x plus 3 cos 2x. Similarly, the next sum is, if I have given you e raised to tan 3x. Anyone? Yes, Abhi?
Yes, ma'am. It will be e to the power 10 3x
Yes.
into sec square 3x
Yes, good.
into 3.
Perfect. See, this is the exponential function. So it is the e raised to tan 3x. The derivative of, by applying the chain rule, the derivative of tan 3x, the derivative of tan is sec square. The theta will remain the same, that is 3x. And then again apply the chain rule, d by dx of 3x, that is 3. Good. Now, if we have, the next question is x y equal to x raised to sin x. Students, if our base is x, our power is also in the form of x. At that time, we apply e raised to log x raised to sin x. Okay, please remember, when our base is x, or we can say in the form of x, and power is also in the form of x, at that time we keep our example in the form of e raised to log x raised to sin x. Both are same, and by applying the logarithm rule, we also write this power in front of the log, so e raised to sin x log x. Okay, all are just y only, all are same. Now we are doing the derivative. So as this is the exponential function, the first derivative is same, that is e raised to sin x log x. Now apply the chain rule, that is d by dx of sin x into log x. Now here we are going to apply u dot v rule, multiplication rule, right? So e raised to sin x log x. Here, by applying the multiplication rule, sin x, keep it the same. The derivative of log x is 1 by x plus log x, keep it same. The derivative of sin x is cos x. Okay, so this is the answer of the example. Now, if I ask the similar example, y equal to sine x raised to x. Anyone? Y equal to sine x raised to x. What will be the first step? I want just first step.
e raised to x sin x log e raised
E,
to
e,
x log sin x.
no, hello, no, anyone?
And we do sine x raised to x differentiation first, then we use chain rule and do differentiation of x raised to x.
Sorry, please repeat.
Ma'am,
We
answer is
differentiate.
cos x.
Please, Karan will give the answer.
Cos x raised to x into x raised to x counts my 1 plus log x.
Yes, see students, this is our main function, sine, right? This is our theta. So our first derivative of this function, the derivative of sine is cos, and the theta will remain the same. And then we are applying the chain rule, that is the d by dx of x raised to x. Okay, you understand? Our main function is sine. So the derivative of sine is cos. This x raised to x is our theta. So it will remain the same. But after applying the chain rule, d by dx of x raised to x. So cos x raised to x. Here, the base is in the form of x. Power is also in the form of x. So I am going to write this x raised to x in the form of e raised to log x raised to x. Right? So cos x raised to x, here d by dx, I apply the logarithm rule, that is e raised to x log x. Now cos x raised to x, keep it same by applying, this is the exponential function, so e raised to x log x, keep it same, and by again applying the chain rule, that is the x into log x, right? So here cos x raised to x, e raised to x log x. Then by applying the chain rule, x keep it same. The derivative of log x is 1 by x. Then log x keep it same. And the derivative of x is 1. Both x will be cancelled. So 1 plus log x. This is our answer of the given example. Right? Now, what about y equal to log y equal to log pi x log phi x upon 10x. Okay, see students, this is u by v. So the u by v rule is v square v derivative of u minus u derivative of v. So if we apply this rule in this example, then y dash is equal to 10x 10x
कर्सरથી નો લખતા હોય માઉસથી નો લખતા હોય
10x. Please unmute yourself. Please mute yourself.
Please mute yourself.
Now 10x whole square, v is 10x, so 10x keep it same, the derivative of u, that is d by dx of log phi x. Now minus log phi x, keep it same, and the derivative of tan x, right? So tan x log derivative of log phi x, that is 1 upon phi x, by applying chain rule into phi minus log phi x, the derivative of tan x, that is sec square x, whole divide by tan x whole square. Both phi will be cancelled. So here answer is tan x upon x minus log phi x sec square x whole divided by tan x whole square. The next sum is, if we have given y equal to e raised to sine x cube. Okay. At that time, y dash is, this is the exponential function. So e raised to sine x cube. Keep it the same. Then by applying chain rule, d by dx of sine x cube, right? So e raised to sine x cube. This is here our main function is sine. X cube is our theta. So cos theta will remain the same, and then again apply the chain rule d by dx of x cube. So e raised to sine x cube, here cos x cube, and the derivative of x cube is 3x square. Okay, so the next sum is, if I ask sine e raised to y equal to e raised to cos x raised to 99, e raised to cos x raised to 99. Anyone? Anyone? Yes, Krish.
Yes, ma'am. The answer will be y dash equal to e to the power cos x to the power 99
Yes.
dot
Hmm.
dot cos will be a minus sin x to the power 99 dot
Minus
9
sine x to the power 99. Yes.
99 into x to the power 98.
Okay. Yes. Perfect. Here, the exponential function is e given. So e raised to cos x raised to 99 will keep the same. Then by applying the chain rule, d by dx of cos x to the power 99. So the derivative of cos x minus sine x raised to power the 99 is theta will remain the same. And then again apply the chain rule 99 x to the power 98. Okay. Now, the next sum is, if you have given cos cube y equal to cos cube phi x, cos cube 5x. Anyone? Yes, Karan. Yes, Karan. Give the answer. Karan. Anyone? Depend. Depend, unmute yourself and give the answer.
Hello. Yeah, ma'am.
Yes.
3 cos square 5x
Yes.
into
Then,
minus sine 5x
perfect. Then,
into 5.
yes, good. Students, here the power is 3. So 3 cos square 5x. First we are applying here x raised to n. Then our main function is cos 5x. So the derivative of cos 5x is minus sin 5x. And then again apply the chain rule. D by dx of 5x is 5. So our final answer is minus 15 cos square 5x into sin 5x. Okay. The next one is, if we have given y equal to log base e x to the power 4, at that time, what will be our first step? This is the logarithm function. So, okay,
4 log x base e.
1 upon x raised to
1 upon x raised to 4 into
4.
4x cube.
So, by
Into
simplifying,
4x.
our answer is 4 by x. Okay. Now,
Yeah.
students, our lecture will be concluded very short, within a minute. If you have any query, please write in the chat box. Otherwise, you can leave the lecture. We'll meet tomorrow for the integration. We'll meet tomorrow for the integration. If you have any query, write in the chat box.